Let me begin to get a temperature of the room, by which I mean not the physical temperature. In terms of content, how many of you are already in the blockchain space? How many of you have heard about it? And then how many of you have read about it? Excellent. Okay, good. And last set of questions, just a demographic question. How many technology providers in the room? And the rest of you, end users? How many end users? Consumers? And the rest is what? Media? Paparazzi? Okay. So I think, I don't know the protocol. I think the doors are welcome to stay open, but let's get on to a sort of a warm start over here. Is this streaming live, or is it it's being recorded for replay? Okay, good. There are going to be two of us that are going to be speaking. I'm going to set the stage, actually more than set the stage, because I'll be talking for about the first 20 minutes. We have 30 minutes altogether. And that is getting some of the foundational aspects around blockchain placed. And then Chris is going to join me in taking us through not just a demo, a couple of demos, but also in the spirit of the forum that we are in over here, take us through the Hyperledger project, which is another very vibrant, up-and-coming open source project, similar to how, let's say, CloudFoundry was just a few years ago. My name is Gurvinder Ahluwali. I'm based in Dallas. I'm part of the IBM team. Officially, my paycheck comes from the cloud side of the business, but it touches the blockchain side of our business. It touches IoT and beginning to touch a lot of cognitive as well. My role is out in the field with customers. Many of you, or some of you who I do know, are in the room, in helping kind of solution all the changes in technology that we are experiencing, both from the cloud side and increasingly from the blockchain side, more to this talk. And I'll just do a brief intro, and then Chris will talk a little bit more. Chris Ferris, over to the front seat on the left side, for me, is a distinguished engineer, and he is the CTO of our open technologies, open architecture, open cloud architecture, and also the chairperson, the elected chairperson of the Hyperledger project, which operates under the governance of the Linux Foundation. He'll touch a little bit more about that, okay? So as must be clear from the title, of course, this is a conversation I want to start about blockchain, and then also in the context of Bluemix, which is the IBM PaaS running out on CloudFoundry, as most of you know. There are three parts that I'm going to touch on in about 15, 20 minutes. Actually, I'll touch on the first two parts and then hand it over to Chris for the last part. One is give you the basics, the essentials around blockchain, and that is definitionally, let's understand what it is, let's understand what its constructs are, give you certain architecture views, help you relate to certain well-known patterns like model view controller I'll touch upon, and also I'll specifically touch on something called consensus protocols. And there's a reason I'm going to touch on that specifically, okay? And then I'll talk about a new genre of apps, if you may, right, called DApps. How many of you have heard that term before? Okay, just one person, one or two or three, okay. So very few of you. So I'm glad that we are able to, Chris and I are able to, from IBM, introduce to you the concept of DApps, which is very similar to a few years ago when the concept of 12-factor apps started and cloud-native application development started. So there's already a new paradigm of application development that has come upon us, and calling developers on how to approach blockchain-based apps. And in the DApp section, I'll talk specifically. You'll see the continuity from the previous section, and that is about smart contracts, certain practices and characteristics related to DApps. And then the developer resources, actually, I'll leave it to Chris to point to the developer resources. It'll really combine with the third section. And then Chris will talk about, he's going to demo to you two two demos. One is marbles, and the other is commercial paper. Just the names of those should be intriguing enough to you that I feel safe leaving the description for later and the intrigue for you right now, and Chris will detail it a little bit more. Okay? That's the plan. Everyone's good? All right. So blockchain essentials. The key distinction, you might have heard of this as a distributed ledger. But the key distinction and a characteristic of the blockchain is that it is decentralized and it has replicated state and replicated content across all nodes. So there is consistency, and how we arrive at that consistency, to give you the teaser, it happens through consensus, which has to precede the replication. Every node on a blockchain network basically has the identical database. Okay? So that makes it not just a database which is decentralized and consistent and identical, but it is also a transaction analysis platform. So it is both a database as well as a new kind of transaction analysis system, right? So transaction analysis is not new to any of you, and I'll make some of the historical connections a little bit later. Now, this being a generic picture, if we look at the constructs, actually, let me just back up to give you historically the contrast. The contrast on the as-is scenario is where every node in a relationship, or every node that needs to transact, or entity, let's not call it a node, maintains their own ledger. Ledger is a fancy name in the blockchain lexicon for, let's just call it databases, okay, decentralized databases. Every node in the current state maintains their own ledger, maintains their own database, even if there is a transactional relationship between two entities, okay? And then you can think about all the reconciliation, all the alignment, and of course, all the audit that has to follow as a result of the databases being separate, even though the transactions are tied, okay? So if the databases become same, identical, decentralized, replicated, a lot of audit and a lot of reconciliation and a lot of friction is removed from the ecosystem and from the economy, okay? Now I'm going to take you through 5 constructs. And think of this more in terms of business before you begin to translate this into technology. And later in the slides, I'll make the translation into technology. One is assets. Assets are broadly of 2 kinds. One are tangible assets, which are physicals, and you'll see chairs and tables and all. And when Chris does the marbles demonstration, marbles are representation, are an example of physical assets. The other category of assets are intangible assets, right? So paper, stuff that is digital, intellectual property, so on and so forth, of course, including software code. Those are intangible soft assets. And Chris's second demo, which is the one called commercial paper, is an example of an intangible asset, an application that uses intangible assets on a blockchain, okay? So that's the construct of an asset. There are 5 constructs I'll take you through. The second one is one of a ledger. I've already described that a little bit to you, but think of the ledger, what you historically know a ledger to be. Here's the transaction. It goes down on one side for one party. Here's how it goes down for another party on the other end of the same transaction. And then you can look at the transaction from a life cycle perspective, and I'd come to an example of buying a car, a new car or a used car, and then you use it for a few years, and then you sell it, and somebody else buys it, and exchanges hands through 4 owners. You get the idea. Eventually goes to a junkyard, right? So there's a complete life cycle, and every step of the way there is a transaction that is happening, and those transactions are getting recorded. So transactions are not just exchange of money, but also represent exchange of transactions. Of course, associated to that could be exchange of value, exchange of currency. Could be associated, all right? And then I clubbed the last 3 constructs over here, and that is participants, transactions, which I've already a little bit described, and then contracts. Everybody understands participants in the ecosystem and in a relationship when a transaction is happening. And the contracts are what govern the rules of relationship and operation of the participants in order to conduct the transactions. I'll talk about contracts a little bit more formally in just a few slides. So if you relook at this picture and I build upon it with, that's the generic picture, and I build upon it with a more specific picture, you see the life cycle in a car as an example of an asset that a car goes through, right? And think about all the paperwork that is involved in the transactions of the life cycle of a car as a property or as an asset. Who owns the asset? What is its licensing certification, state licensing, DMV kind of papers, ownership, insurance, so on and so forth, right? Who's driving it? Who's borrowing it? There are a lot of aspects to it, okay? There could be telematic aspects also to it. I'm not touching on necessarily the telematic aspects over here, but you could also look at that as another digital chain that happens in automotive. So this is something that you can relate to. This is an example of a tangible asset, and these kind of transactions can go on a blockchain, and each of the entities in that, each of the nodes represents an entity, and the entity records the transaction depending on the movement and the stage of the life cycle of the vehicle. So that was a car use case. This is an IoT use case, probably closer to a consumer connected home kind of an IoT, but you can think of it similarly in other IoT situations, where the devices, so these don't just have to be financial transactions. Finance could be an element of it, right? So the devices that are talking to each other could be nodes on a blockchain, which now become homogeneous, meaning the blockchain and the user is agnostic to the individual devices. The reason I point out the word homogeneous is because that's one of the barriers to large-scale adoption of connected home. Heterogeneous devices don't talk to each other and so on and so forth, but how do you take that problem away? By lifting it into a layer, which we call the blockchain, and then having the rules and the transactions and the trust between devices through the blockchain. And now you can begin to look at a car talking to the vision that everybody has seen painted in the industry, can come to closer to reality, where you now get not a device-centric experience, but you get a user-centric experience with trust between devices and governance that you can apply through the blockchain. There's several other examples, several other use cases, but the most important point in providing only a very short sample of the use case list over here is to compel you to understand that it's going to touch all of you, regardless of what your industry is. Because the nature of transactions that we are talking about, which can come into the scope of a distributed ledger, is basically anything and everything, for the large part. Now, of course, there's more mechanics and design aspects to it, meaning public versus permission and scale and certain design points that I'll talk about in just a moment. But there are use cases and actual execution happening in the market. This is not just visionary around land rights. In countries where land rights aren't very well developed, and property ownership of land is put on a blockchain, and it stays there, and there is no dispute about it, and it's very clear when handoff and exchange of a land or property transaction happens. Provenance is when a company wants to know exactly where its individual component parts of a product are coming or service is coming. Think about pharmacy. Think about aviation. Think about luxury goods, right? Think about healthcare, right? Those ecosystems are very sensitive to where the supply is coming from, where the supply chain is coming from. How do you get the right governance and the right provenance around that? All those are examples and use cases for the blockchain. So I'm stepping into kind of my second section, which is to begin to give you, now that we painted a picture around the blockchain, and by the way, I forgot to mention one of the key words. Once you get a little bit deeper into this, there's a whole language and terminology that is developing. The transaction and what is saved in the blockchain database is immutable, right? So which is different from typical databases where you can go and do a delete. In distributed ledgers, in decentralized ledgers, you cannot delete. So once you save something in it, it is saved in there for life. So now you can begin to see, not just does everybody have an identical copy, but what is in it is immutable, okay? So I'm going to move into the architecture view, and this is the model view controller pattern that I alluded to earlier. And if you begin to think of your stack, a typical stack on the left side, right? Begin to think of that, and I'm going to basically build it up and trying to relate it to a blockchain-based stack. And you have transaction systems in your environments today, right? The middle portion of the platform stack, okay? So think of this, think of blockchain-based stack, very similar to the stacks that you have, but of course very different in its own unique and differentiating ways, where you look at it as another transaction system that is part of your environment. Just like cloud became part of your environment, right? And beginning to expand and legacy begins to shrink. Similarly, think of your transaction systems and opportunities for new transaction systems, either existing ones moving or new ones being built with applications built on the blockchain. So I'll step you through real quickly through these layers. And starting from, let's just start from the bottom. The point being that security is, of course, not just hardware, but also security at the hardware layer. And there are hardware companies that are doing a lot of work, both at the chip, right at the chip level in terms of security. And then you come into consensus, which is a really important point. And the reason I flag that out is because it sets me up to talk about on the next slide, which is devoted only to a certain sample of consensus protocols to, for you to kind of keep, take under your belt for further consumption. So blockchain, the core fabric, right, is abstracted out from the consensus capability. So from the IBM point of view, and increasingly from the community in the Hyperledger project, Chris will talk a little bit more about that, you begin to see consensus as a service. So it is not loaded and wired into the Hyperledger core, and now you get to pick and choose which consensus protocol you use. Park that thought in your mind for a moment, because I'm going to come back to it. Why the choice of a protocol and having flexibility in which choice for your use case and for your market conditions is important. I'll talk a little bit more about that in the next slide. Then, of course, your crypto capabilities, messaging capabilities across blockchain nodes, and then smart contracts is the other layer that I will highlight a few slides down. And built on top of smart contracts are applications, which in this world are called dApps, and I'll elaborate a little bit more about that in just a moment. So here are some terms that you probably never heard of. Quite frankly, even I had not heard of until started delving into under the hood of this engine. On the top left is something called BFT, or Byzantine Fault Tolerance, or PBFT for Practical Byzantine Fault Tolerance. Praxos is another. Let me just throw the words at you, and then I'll elaborate. Rafter is another one, and Sieve is another one. Okay. Now, to make the connection for you, these are the protocols which stand in the layer over here that you see called consensus or consensus protocols. There are lots of choices. This by itself is becoming a very vibrant subspecialty in computer science schools today. A lot of research happening in new kinds of consensus protocols that are evolving. Now, some of these are new, and some of these actually have existed for 20 years. Byzantine BFT has been sitting on the shelves from MIT or somewhere for the last 20 years, really hasn't gone into wide-scale application. But the Hyperledger project, right, which is the open source blockchain project, IBM is significantly invested in that, is going to use, at least for the first release, the BFT protocol. If you're familiar with Bitcoin, which I'm sure all of you are, and underneath of Bitcoin is also the blockchain, which is where all this innovation and disruption started. But the distinction to note is that the Bitcoin blockchain is vertically integrated for Bitcoin. So think of Bitcoin as the application. Think of Bitcoin as the application, and the blockchain underneath of Bitcoin as a vertically integrated, specific to Bitcoin. That's the blockchain for it. And the consensus protocol that it uses is proof of work, which is not shown over here. Okay. So the choice of the protocol affects significantly the use cases, the market behavior, and also the fairness of a blockchain market so that nobody corners power and of the transactions matters significantly, okay? I won't elaborate too much just in the interest of time. Raft is another very popular protocol, and actually you may not even know this is something that is used in the Zookeeper Hadoop H-based world. So I see some heads that are nodding. Paxos has been around for some time, I believe, but it's also very complex. Sieve has some more refinements on top of BFT for eliminating or minimizing non-deterministic behavior. I'll skip this, but the main idea is there are certain design points that are important when you're designing a blockchain node, meaning which node should take what entities and what roles. There are different roles, as you can see, that nodes have. A node first, by default, boots up as a validator node, and then issues a request, a broadcast, saying, are there other validators over there? And then it finds out whether there are other validators or not, and then takes on, there's an exchange and a protocol communication that happens, and then nodes take on different roles, based on the protocol and based on certain security and privacy services. How many transactions can be run on a node? So there are a lot of design aspects that come into play when you're designing a blockchain network, besides just picking which protocol it is. I'm going to skip the letter of credit use case, but the idea is you begin to see the movement of documentation and goods across a set of parties. I spent a few minutes on smart contracts and dApps and leave sufficient time for Chris in a few minutes. All right. Everybody knows what a contract is. So I'm recapping what the lawyers have told us, right? So it is an offer. It is a meeting of mind. It has to be accepted by both parties. It is a promise to perform. And because it's a promise to perform, there has to be consideration, meaning value has to be exchanged. There's usually a timeline and an expiration associated with it. There has to be proof of performance, so the consideration can be exchanged within the timeline. And there has to be remedies. If somebody does something bad, then how do you do mediation, recovery, and those kind of things? Somebody breaches, okay? That's a contract. In many senses, a smart contract is not different, but you should not expect it to be just a codification of traditional contracts into software code, because there is more optimization. You can get more granularity and features and control on the contract. You can release payments on much shorter intervals depending on movement of a cargo from country A to country B, depending on the progress of exchange of tangible assets. You can have more finesse, more control, a richer contract if you have it in terms of a smart contract. Smart contracts run on nodes. There's certain privileges nodes will have, which ones can run, what kind of smart contracts. And if you think about the stack diagram we looked at, smart contracts are what invoke the submission onto the blockchain. They invoke a request onto the blockchain, and therefore also invoke the consensus protocol underneath of it. Back to a car ownership problem real quick. I think I described to you the current state where the databases are different and each has an in-house database. And the idea being now everybody has a yellow, identical, shared, distributed ledger. The reason I put up that slide is to begin to introduce you to the concept of dApps. And there are three things in the dApps if you look at it holistically. One is, of course, the application per se. And in the middle, you'll see something called chain code. Think of this as the layer in the stack diagram, which was the smart contracts. In the Hyperledger project, in the IBM term, chain code is basically the implementation paradigm for smart contracts in Go. Chris can elaborate a little bit more on that. That's chain code, and then chain code writes to the distributed ledger, the blockchain at the bottom, okay? So those are the three essential constructs of dApps and how new kind of apps are built. And here are some more properties. I'll leave these mainly for you. This is just a narrative around the previous graphic, around the characteristics. Actually, just real quick, there's a last point over here. And you look at the characteristics of dApps. And you think of them to be abstractions. This is a new form of programming abstraction you're now looking at, right? So you think of contracts, not in terms of objects. You think of contract-oriented programming as opposed to object-oriented programming. There is no entity that controls the majority of the tokens. Protocols, as I described, the consensus is as a service, adaptive based on use case of the market, and you avoid any central points of failure. And if you think about it on the right side, the 12-factor app, everybody's familiar with, this builds upon that, right? This is not in conflict. Everything underneath of this is intrinsically in the 12-factor application constructs as well, all right? So let me give it to Chris to take you through a couple of demos.
Thank you. Let's see. Hello. There we go. And all right, so the first one I'm going to show here is marbles. So we've written a couple of sample apps on the Hyperledger platform, Hyperledger Fabric platform, I should say, to demonstrate essentially what's going on in the internals. And each of these samples sort of gives you a sense of how to actually create an application that leverages the blockchain. In this particular case, we have a very simple demo. We have Bob and Leroy, and they have and can trade marbles, right? So I can move a marble from Leroy to Bob, and as you can see down below, that's getting recorded in the blockchain as a specific transaction. I can create a new marble. I can give it a color. I can say I like this one to be, nope, I already have a green one. I'll make it blue. All right, and I'm going to make that large and give it to Leroy, and boom, we see another block get added to the blockchain. Where did he go? Hello. All right, that's not good. It's not getting validated, as I think was going on here. Yeah, it hasn't been validated. Why isn't it showing up? Let's create another one. Let's give this to Bob. Red. There we go. Now they show up. Okay. And then I can trade them, but you notice that this is immutable. So, once a trade is recorded, it's recorded for both. I have 2 nodes in this particular demonstration, and it gets recorded on each, and I can go through and I can inspect the blockchain there. The second demo that I want to show is sort of the commercial paper. So this is an application where one company may put out and offer to give a loan to a customer so that they can buy their product, right? So this is something we call commercial paper. And so I have myself, and then I have Guri all logged in here, and we're going to trade some commercial paper. Whoops, that's not what I want. So I'm going to create XXX, $100,000 note. So I've just created a $100,000 note, put it in there, and that's now available for Guri to pick up. So he can actually purchase that note right there so that he can buy something from me. And so we've just executed a trade, and if we come down here, we can see that all of those are then recorded in the blockchain. So again, these examples essentially give you all the tools that you need to be able to write a node application that interacts with the blockchain, shows you how to write the smart contract in Go, and deploy it to the ledger and so forth. Let's get back to the demo, since I think we have very little time. Hello. And demos. Okay. So when we started exploring all of this, one of the things that we recognized was this is the perfect type of thing that's suitable to open source. At its essence, blockchain is going to be something that's going to be, I think, as fundamental as the web. If everybody runs off and implements their own blockchain technology that doesn't interoperate, we're never going to be able to create these various use cases that you saw. If we're going to have, supply chain transparency right? You're not going to have a single vendor solution across an entire supply chain. So it's very important to us that we actually created an open source project. And so this brings us to the Hyperledger. So, I worked with Jim Zemlin, some of the other guys at the Linux Foundation, and we recruited a bunch of friends. We now have 48 friends in the Hyperledger project. We started out with a total of 30, and we've had two, in just the past 3 months, we've had 2 additions, one of 10 and one of 8 just last week. New additions, new members of the Hyperledger project. We have sort of monthly hackathons where we get the community together, community developers together to either to start hacking on and creating Hyperledger-based projects, applications, and or to hack on the platform itself to bring new members into the fold. It's not quite exactly the same thing as the CloudFoundry Dojo model, but again, there's an awful lot of pairing and stuff that goes on as we start bringing people into that community of development. We've got a number of activities ongoing. We're building requirements and use cases. This is sort of exploring, the landscape of use cases that Guri was sort of hinting at. We've got an architecture working group that's sort of exploring how we want to compose this from a pluggable perspective. Identity working group that's focusing on the various schemes that we have to manage identities in the blockchain. And we've got a group working on creating a white paper that's giving us a point of view across all the different types of things. We're essentially, if I were to net it out, I would say that the project is intending to be the analog for blockchain that the Linux kernel is for Linux. We expect there to be one kernel and then many distros and many various solutions building off of that kernel. So again, that's sort of reflected in the white paper. We have 2 incubators. We have the Fabric incubator, which is based on the IBM contribution in collaboration with Digital Assets. And then we also have the Sawtooth Lake incubator, which is a project that was contributed by Intel. It implements a blockchain, and it introduces a new and very novel form of consensus, something they call proof of elapsed time. It's a little bit more complicated to get into, but basically it sort of replaces the notion of proof of work. And we're looking at, just this week, we've been working on getting the whole release integration process up and running so that we can potentially be able to cut a couple of releases in the June timeframe. I've left a couple of links here. So we have, obviously, Bluemix. All the demos that I was showing you were actually running on CloudFoundry. They're CloudFoundry Node.js applications that interact with the blockchain peer network that was running in a Docker Swarm cluster with 2 validating peers. So we've got that. You can check those demos out. They're also available on GitHub. You can go to github.com/IBM-blockchain, and you got a number of other additional demos and samples there you can toy around with. And some additional links here to various resources, including the Hyperledger project, hyperledger.org. Again, it's open source. It's free for anybody to come and contribute. And we'd love to have you come and hang out. And that's basically it. Any questions? Any questions? Yes?
So can you give an example of how the choice of the consensus protocol affects the use case or the type of applications that you would be able to build?
Right. So the question is, can I give an example of how the choice of consensus protocol would affect the nature of the application that I wanted to build? An important point that I think, again, this is a half an hour is too short to cover a lot of this stuff, but if you think about Bitcoin is a permissionless network. Anybody can join, and the choice of consensus is important because this proof of work notion is what assures that everybody is seeing the same picture, right? It's fairly complex, but basically because anybody can join, you have to sort of pay to get in. And the way that you pay is to do this, is to solve a puzzle. Solving the puzzle requires that you chew up an awful lot of CPU, and the thinking is, well, if you're chewing up CPU, you're actually spending a good deal of money paying to the electric utility to do that. When we think about some of the use cases there, those are going to be in what we call permissioned networks. Those are going to be where maybe a collection of banks or participants in a particular supply chain would get together in a closed network, if you will. And because you know who the members are of that, then you're less likely to fear that one of the members of your supply chain or one of the members of your banking consortium is a bad guy that's going to try and do some bad things with the shared ledger. And so as a result of that, we can choose one of those other consensus algorithms like PBFT or Civ or something, or Raft. And because we know the set of members in that network, we know how large the network is, then we can figure out whether or not we've achieved consensus just by counting, right? And so as a result, you would choose some of these different algorithms to essentially achieve greater throughput in those kinds of networks. And again, there's additional exploration ongoing to figure out, we can have some where we have a collection of validating and non-validating peers that participate, and that way you can even constrain further the number of validating peers helps to increase the throughput because it takes less time to achieve consensus. And there's additional research that's ongoing about various other forms of consensus that we might choose to use. R3 came out with something called Corda very recently, and their notion of consensus is just the two members participating in a given transaction are the only two that have to achieve consensus. So if they do, boom, then we're good. So there's an awful lot of different approaches depending on, again, the nature of the kind of network that you're creating. Okay? Yep.
If I'm a small business and I try to collect money over the web for anything, so I can't store, for example, credit card data or something, and I need to be PCI compliant and all those things. So how do you see Hyperledger or blockchains easing that pain for, let's say, commerce over the web?
So as I mentioned, so the Hyperledger project is focused on sort of the core implementation technologies that you can use to construct a blockchain. It's not a specific solution. I would expect that the people that building sort of on the solution layer on top of that technological capabilities are the ones that are going to answer that particular question. I mean, obviously, those use cases and requirements feed down into how we build this technology, but it's going to be the solution itself that determines that. Does that make sense? Okay. Yeah.
Ethereum and Hyperledger, how would you convince me to go with Hyperledger and not Ethereum?
Okay, so that's a good question. So the question is, choosing between one of the other implementations of blockchain like Ethereum or even Bitcoin itself, or there's a number of others, Ripple. And the answer to that question is we're actually in the process of collaborating with members of the Ethereum community. And one of the things that we're looking specifically at is being able to take the EVM, the Ethereum VM approach to doing smart contracts and porting that and writing that into the context of the chain code example that we just showed. And the Ethereum community is very excited about collaborating with us. So I don't think it's necessarily going to be a choice. I think it's more likely that these things start coming much more together under the umbrella of the Hyperledger project. All right, I think there's another, yeah, thanks, Chip. Thanks for saving me. So thank you.